My name is Mike Lee, and I'm a Senior Product Manager with Teledyne FLIR. And I'm really pleased to share with you today some insights that we have with respect to the spherical imaging market and the applications that spherical imaging solves in the world today. So the Integrated Imaging Solutions Division has been in operations for over 25 years. And over 20 years ago, in 2002, we launched the first spherical imaging device called the Ladybug family. Since then, we have released products in 2005, 2008, 2013, and the Ladybug 5 Plus in 2018. As a product manager, I get the benefit of speaking to prospects and customers around the world and hearing what their needs are for spherical imaging applications. I have a diagram here which I'll start at the top and work my way around. But the first thing that they ask about is that they need to image both indoors and outdoors. And when they're imaging and capturing imagery outside, they need an industrial ruggedized camera that can operate under all weather conditions on a moving platform. Spatial accuracy is extremely important and critical to their applications. The need to be able to trigger a capture of an image in line with a GPS in order to capture that actual position is very important, as well as the per pixel accuracy of the actual image, every pixel captured within the frame. With respect to a commercial grade SDK, it is very important to our customers that they are able to go and set the control settings of a camera, as well as read those settings, and then integrate the content into a larger workflow. So a comprehensive, well-documented software development kit is an important aspect. Manufacturing quality consistently at scale is important to these customers. Starting from their first camera to the 10th camera or the 100th camera, they expect the functionality to be consistent, the quality to be consistent, and the imaging performance to be consistent. And that's critical to them in their business. Of course, they want a manufacturer that can stand behind their product. A well-comprehensive warranty, and the fact that many of our customers buy a camera component and incorporate it into their system means that they have their own product lifecycle. So our ability to support an extended life cycle that meets their needs is critical. Because we have customers that are global and operating in all continents around the world, the ability to have world-class support and access to people that have knowledge about the product, the technology, and can solve their problem in the shortest time possible is critical. And of course, having a reliable track record of producing a product, backing it up, and enabling business to be successful, especially when you have a camera that is expected to operate in heavy-duty cycles, 8 hours a day, 5 days a week, for years at a time, our product family is proven in the field. So I'm really pleased to introduce to you the latest product in our family called the Ladybug6. It is a camera that can image at 72 megapixels at 15 frames per second. It has been certified by a third-party testing agency with a protection rating of IP67. It can operate under extended temperature ranges, so as low as minus 30 degrees Celsius and as high as 50 degrees Celsius. And it can be triggered by a GPS source to capture that position precisely and accurately. And then the per pixel accuracy is at plus or minus 2 millimeters at a 10-meter distance. So I want to give you a sense of what 72 megapixel resolution is. Many of you are probably familiar with full HD or 1080p. That's an image that has 1,920 pixels wide across, right? And you may be familiar with 4K video or 4K images. That is twice the width and twice the height. That means the image size, each image is 4 times the size of an HD image. If you go to 8K, It's 4 times the width and 4 times the height. That means an 8K image is 16 times the size of a full HD image. And when we're talking about the Ladybug6 producing a 72 megapixel image, that is 12K. That is 6 times the width and 6 times the height. 36 times the size of a full HD image. And this camera is operating at 15 frames per second. So let's talk a little bit more about why performance and image quality matters. Our customers need the performance to capture the content based off their application requirements. So if you need this type of resolution, and for example, you are doing highway inspection, you may need to operate your camera while you're driving on the highway at 90 kilometers per hour, and therefore you need to capture this image content at 9 frames per second. If you need to capture an image every 3 meters. So 3 meters spacing, 90 kilometers per hour, you need to capture it at 9 frames per second. If you are doing railway inspection and the train is traveling at 150 kilometers per hour and you need that 3 frames per second, you need to be capturing it at 14 frames per second. If you are operating a bullet train at 400 kilometers per hour and you are willing to accept 8 meters spacing, you too need to capture this content at just under 14 frames per second. So depending on your requirement, having performance is critical. Having high performance in image quality is critical because now this allows you to do your job in the most efficient manner. And efficiency means shorter time. If you can do your job in a shorter period of time, you're reducing costs, and now you're delivering value to your customer. So I talked about image quality. Let's look at this image in full here. So when we captured this particular frame, it looks beautiful, right? It's a blue sky, sunny day, bright sunshine. But this type of scenario is extremely challenging for a spherical imaging camera. The reason why is because you have the intensity of the light source, very bright within the scene, but it's important that you capture detail within the least lit portion of the scene. And this is a spherical imaging camera, so you're capturing the entire sphere, the entire panorama around you. So having a look at this image, on the right-hand side, you see the sun shining directly into the camera. And you can tell that those pixels are oversaturated because of how bright that light source is. But notice right beside it, on the right-hand side, that car entering the shaded area. If we zoom in, you can see that the characters on that license plate are still recognizable. And that license plate portion there is from a crop of the image that has not been processed at all. You can run very quickly image processing algorithms to go in and drive and extract those characters even more clearly. On the right-hand side, you see the buildings there, the apartment buildings. From a spherical perspective, that is actually directly opposite from the light source from the sun, which is why it's so bright on those in that building. But you can still discern the balconies and the windows in this image, even though they are brightly lit. And then on the far right-hand side there, you see that electrical utility box. That is another example of a critical application that many of our customers are striving to achieve. They want to be able to identify assets that are important along the roadside, and then extract the identifier, the label associated with that asset, so they can assess its condition and record the metadata about that asset. So image quality is extremely important. Let's take a look at this next image with respect to this utility asset and talk about why resolution makes a difference. So over here we have that same utility box captured using 2 different cameras. On the left is our Ladybug 5+ camera at 30 megapixels in resolution. And on the right, we have our Ladybug6 camera, our newest release model, capturing this utility box at 72 megapixels. And you can tell visually that on the right-hand side, the characters are much more clear for us with our eyes as humans. But what's really important to consider is that the way that this becomes a real business changer for our customers is in that fact they're using computer vision algorithms to identify these assets. So identify the shape of these assets that are critical to them on the side of the road. It may be an electrical utility box, it may be a fire hydrant, it may be a telephone pole, but these are assets that are important to be tracked and understood, and then reading the identifier on these. And so what you want is you want the computer vision's optical character recognition software to be able to extract that identifier associated with the asset. So with the increase in resolution, you are able to identify assets that are farther away from the camera with identifiers that are at smaller size. That is a huge benefit you get with the increase in resolution. I want to take a moment and speak about the different markets and the applications that we have had in our roughly 20 plus years of spherical imaging. There are many ways to try and describe these markets and the applications, but one way that I'm using it here in this slide is to group them into maps, roads, and utilities. So let me speak about each one of these applications very briefly. With respect to maps, there's everything from street view imaging. So that's the panoramic view that many of you are probably familiar with. You go to Google Maps, and you drop yourself into a position all around you, panoramic, full 360. That has been around for a decade and a half, and a very common and consistent use case because those maps need to be updated on a regular basis. But a growing demand is in the high-definition map generation space. So high-definition maps are being driven by the need to support autonomous vehicles and autonomous vehicle driving. And what we're trying to derive in here, and often this is combined with LiDAR scanning to get down to centimeter level precision, is that you want to extract the curbs, the lanes in the road, where the lines are, again, the stop signs, the traffic lights. That information is critical for them to build those autonomous maps for those vehicles to do the driving. With respect to roads, road inspection is a common application. It's about the ability to determine the texture and the grade of the road surface, identify the cracks and the potholes in the road. And this is critical because the end users are typically cities and city property managers that are responsible for maintaining the condition of the road infrastructure to a certain level. And they have a limited budget, and so they want to know where they can most effectively spend that limited budget to maintain and update those roads on an annual basis. Land surveying is another one that's common, that's being used commonly with LiDAR scanning. Again, it's about trying to assess the composition and design of existing as-built. And for example, if you're trying to generate the engineering plans to replace a highway overpass, it's really critical that you get the image data to be able to classify and segment the actual material of that as-built so you can actually make a proposal in the most efficient manner. And then the last category I have here is under utilities. You saw that example of the electrical utility box. It's about, again, identifying assets that are responsible to be managed and maintained and assess their condition and figure out how best to use the limited budgets to do an update, maintenance, or replacement. And a growing space is in the fiber to the home or fiber to the business space. Right? So this is how utility companies need to figure out the optimal manner to route conduit from the main trunk of the road to every single address. And what they're trying to do is use the image data to understand the terrain in front of every single address and figure out the optimal engineering plan based off whether or not you're going through, you need to go around the concrete of the driveway and route it through the soil of the garden, because that is just the optimal path. It means a shorter period of time to work at that particular site and drives down the cost and minimal disruption to the business or homeowner at every one of those locations. So that's driving that business case. So that's what I had in a snapshot to share with all of you about spherical imaging applications. I'm open to questions at this point in time. Thank you very much for your time. I can pass the microphone. Oh, thank you. Any questions? We've got a microphone here for anyone who has one to ask. Now, just as a note, if you're interested in looking at some sample imagery, sample video footage, looking at some of our... Oh, hi there.
Yeah, hello. Just like to know, earlier, because you touched on earlier slides that specified spatial accuracy as plus and minus 2 mm, right? Can you just elaborate on what does this refer to?
Yes.
Thanks.
So I mentioned earlier that our cameras are calibrated out of the factory to have a per pixel accuracy of plus or minus 2 millimeters at 10 meter distance. So we use a geometric model of the entire camera. So every single, let me just go back here. See this camera here? There are 6 independent lenses and sensors, 5 around the horizontal plane and a 6 looking up. And so what we do is, when in the factory, we go and capture and calibrate this content against known targets in the factory, and then we fit the geometric model in software to have all the sensors fit into a sphere. And what we're able to then determine is, using that model information, feed that calibration data into the firmware of the camera. So every camera has that calibration information modeled, uniquely set into the camera, so that when the camera is actually capturing images and we reproject it out into a sphere, we know what the actual error is. There's more information that we publicly post on our website that describes this model, and we expose the actual model, the geometry, for all our customers to see. It's publicly available, and it talks about how, in reality, every single imaging device has a model for error, from optics to the sensor and through the entire processing value chain. And so to understand that, we share that information with our customers. So that's what I mean to plus or minus 2 millimeter accuracy at 10 meter distance.
Are the pixels geo-registered?
You can, that type of, remember I was talking about how you need to make sure that it is timed with a GPS unit for triggering, and then have that spatial accuracy. That is exactly why, because customers often are also capturing other sensor data, such as laser scan data, and they want to be able to register accurately that color with that point cloud, or each one of those points in the point cloud. So I think my time is up. Please come over, visit us over here at the booth right over here, G21, under Voltrium. That's where our Teledyne FLIR group is presenting. You want to see some sample imagery, sample video, have a look at the camera itself, it's all right there. Thank you very much.